Hey guys, here's that example that we didn't have time for in class, the one involving the square roots. You can't factor this. There's nothing we can really expand. We certainly can't plug in zero. So what we have to do is multiply by the conjugate. So we need to get this square root sort of rationalized, kind of like when we used to rationalize the denominator. If you remember back in algebra, you'd have a square root down here and they would have you multiply by that square root over itself. But we're actually going to do the same thing here. The only problem is I can't just multiply by square root of x squared plus 9 because I'm still going to have this 3 to deal with. I'm going to end up with 3 square roots of x squared plus 9, and that's not going to help us. So you multiply by the conjugate. So we're going to basically multiply by the exact same thing, but switch the sign of the connection between the two terms. Okay, so multiply by exactly what the square root is, exactly what the other term is, but just change the sign. And if you do it to the top, of course, you got to do it to the bottom, so that you're really not changing anything. You're just rewriting it because really you're just multiplying by 1, right? Anything divided by itself is going to be 1. So we're just manipulating this. So look what happens. Well, the whole point of multiplying by the conjugate is to get the square roots out, like I said. So square root of this thing times square root of the same thing is that thing. Square root of x squared plus 9 times square root of x squared plus 9 is simply x squared plus 9. Think of it like this. Here, I'll do it over here. The square root of 5 times the square root of 5, right? That's the square root of 5 squared. But when you square a square root, or take the square root of something squared, same idea, you end up with exactly that value. Same idea. So that takes care of the first part. The minus 3 of these things cancels with the positive 3 of those things. So the O and the I of FOIL, the outer and inner, cancel out. That's the beauty. Negative 3 times positive 3 is negative 9. The denominator, here's a pro tip. You're going to be tempted to distribute everything, but don't. Just rewrite it exactly as it is, x squared plus 9 plus 3. The whole point is to try to eliminate the term that's causing the trouble. This x squared in the denominator is causing all the trouble because x can't be 0 down there. As soon as we can work that out and factor it out, we'll be able to substitute in the 0 and figure out our limit. So let's keep cleaning this up. This is going to be the limit as x goes to 0. X squared plus 9 minus 9, well, those cancel. That's convenient. Over the same exact thing, but now you can see that the x squareds actually do cancel out, leaving you with this step here. So 1 over the square root of x squared plus 9 plus 3. And while we couldn't substitute in the 0 to find our limit in the first, original example, once we manipulated it and simplified it, now we can. Putting in your 0 to find that limit is going to give us 1 over the square root of 9 plus 3. That's 1 over 3 plus 3, which is 1/6. Okay, I think we actually did one like this in class before we learned this technique, and I had you use your calculators. I believe this is the one where we kept getting like 0.1666666, and we kept debating as to how far out it would go. Well, it turns out it is exactly 1/6. So anytime you see a square root with one of these limit problems, this should be your sort of go-to strategy, is to use the conjugate. All right, I hope that helps. Obviously, let me know if you have any other questions, and have a great weekend.